Hello, everyone. Welcome to ModX Network Voices. My name's Ryan Smith, Washington State University. I'm joined by my partner, Ivan Rupnik. Ivan?
Hey, Ryan. How's it going?
Thanks for coming. And Joel Hutchines, we met a while back. He's with Splash Modular. And Joel, like us, was crazy enough to become an architect first and then go in and try to make a difference in the construction industry. We're seeing that this is a growing trend in the ModX Network Voices. Folks that start in architecture, try to make an impact, realize they can use their skill sets to influence different parts of the sector. And Joel is trying to reconsider the digital process tools and modes of delivery for design, manufacture, and construction. So welcome, Joel. Appreciate you coming and spending some time with us.
Thank you, Ryan and Ivan. It's a pleasure to be on here. I'm excited to share more about my crazy career path, but also where we're headed.
Great. Now, Joel's prepared a few slides. He's going to talk through his story as he started as an architect and then moved into fabrication, and then his recent venture and where he's making quite an impact at Splash Modular and what that concept and tool set is for the industry. So Joel, please share your screen and go through some of these ideas, and then we'll have a Q&A session after that.
Sure. Well, just bear with me and I will pull this up and we can go from there. So I guess to first understand how I ended up where I am and in this crazy career path, I started in carpentry in Australia. I did my time, from cutting lengths of lumber to lugging around material around the building site. That then progressed into building, into the GC sector, and working there and trying to control more of that project, which then led me to architecture school. I really found a passion for the design and that whole process, but it wasn't until I got to architecture school that I realized what an asset it would have been or is to have that background as well. As I progressed there in architecture school, I really discovered computational design and the skills and ability that I could use my experience in the building industry and then apply that through computational design to really progress the logic of digital fabrication and file to factory. Once I finished architecture school, I worked for Shigeru Ban in Tokyo. And that was where the computational design and the digital fabrication could really come to another level, and I could test that and see that in real projects. And then whilst working there, I really discovered the idea of DFMA, and not just design intent or designing and documenting, taking the logic of what how it was going to be built, and then using the computational skills to minimize the documentation and take that directly to machine so that we could have this design for the manufacturing for the machine, but also for the assembly and really the ease there. So once I returned to Australia, I co-founded Studio Workshop. You can see there, design, fabricate, build. We were crazy enough to look at the entire life cycle, the entire process and project, and take that logic of what we could do with computational design and digital fabrication, but also push it and really resolve things as far as we could in the design, using the computational skills. So a highlight project here was this house in Papua New Guinea, and it's curvy wavy timber. Some may say it's curvy wavy timber for the sake of being curvy wavy timber, but it was really the idea here that we could use computational design, digital fabrication, and DFMA tactics to create something that was at a reasonable price, but in a place like Port Moresby in Papua New Guinea. So built in Australia, shipped there to site, and then come together with the really unskilled labor on site. So the approach that we sort of took was we took that computationally, and we had this dynamic service that we could create, but then we built all of those skills in. And you can see here, the process. It was then dividing that surface up into the parts, but then associating that with the actual timber members, and also in real time looking at how that was broken down into larger panels again, and then how that was shipped. This logic actually took into account fitting it into one shipping container. So the curvature and how far we took the craziness of this facade was really, we're looking right the way down to the full delivery of the project. And then you can see there that the nested components and how we looked at sheet efficiency or material efficiency at the same time. So this was where we really took the idea of taking those skills or building our own tools to take control of the project. Yeah, here you can see some photos in our factory where we had unskilled labor putting this together, and the detail that we had the dowels there in position so it couldn't go together wrong. And then the next level of how that then was taken to site and assembled. This was an approach that we took through all of our work. You can see all these projects here. A lot of it is curvy, wavy timber, but it was really looking at the skills or the tools that we had available in terms of the digital fabrication, but also controlling that computationally and right the way down to what the material could actually do. So the bluey, the light show there in the middle, that's actually HDPE, and that was taken to a whole nother level of what was actually achievable, but then built back up in the script. So once I sort of had that approach, I consulted to general contractors with setting up bathroom pods, facility and in a modular space. And it was really highlighted there that this pre-construction process of losing data and interpreted data the whole way through and how inefficient, and really looking at how the approach we have with Studio Workshop, but then also how we could take that to the masses, and how that could increase industrialized construction uptake. And so there was sort of two approaches, and it was the vertically integrated business model there that was really the buzzword. Everybody was talking about it. They were still partaking in the same breakdown of process. And what ended up resulting from that is a big preach for standardization. So they were looking at this inefficient process and saying, if we do that once, then we can replicate it and we can mass produce it. We don't have to keep doing it. And that really didn't sort of got my back up a little bit in the built environment. Is really, we don't have that opportunity to standardize to that level. What would happen if we had the replicated buildings with no site or context relevance? It's sort of sad, and it's sad for architecture. So that was where we went to the next level, and we said, well, let's take a bathroom pod, let's create a kit of parts, build an algorithm, automate the process from file to factory, and running that supply chain, and then have localized assembly so we can have those parts show up to a local assembly line and come together very simple. And then how far can we drive the innovation? So can we take that script and start to look at material efficiency, start to look at all these extra things that we did? And that was where we created this idea of a product, a digital product. So rather than sort of the one-off services, we could actually take something that we could design and turn it into a customizable digital product. And that's where we developed, where we can put in inputs, manufacturing constraints, logistical constraints, supply chain efficiencies, engineering, material, all these extra things we can put in. And then on the back end, we can automate the full delivery. So we can get G-code to run machine out of it. We can get all the project scheduling. We can get the purchase orders. We could actually control the delivery and the critical path and full BOM approval drawings. Everything can be automated. And then for us, it was really, well, what does that unlock for the industry? But we had to prove it out. So we proved it out with the bathroom pod, which we see as a multi-trade CDP. So it's made up of single trade. So you can see there that the walls are one single trade, or the GFRC base is a single trade. So that led us to breaking it down into full building typology. So you can see here there's system CDPs, there's multi-trade CDPs, single trade CDPs, and material. So by creating a full digital thread through the whole supply chain, or for a typology, we could actually restrict the design to what was achievable via the supply chain or with the supply chain, but then also automate the process. And for us, that was really that took the industry, brings the industry forward, if we took that approach. So what is the future? If we look at that, it's collaboration, it's leveraging technology, it's creating products rather than offering one-off services ongoing. And then it becomes a new marketplace where we can increase productivity and lower costs and risks. So it was really, how do we come to market now and bring the industry forward into a new marketplace where it's not one-off services, where we can create customizable digital products. So this is sort of breaks it down. So when we build a customizable digital product, we have the assemblers, the manufacturers, material suppliers, consultants, and then we will build those customizable products and we make them available on Riveia, which is the marketplace. So what you get is a supply chain knowledge data, creating a component, bringing that up into the cloud, where that is a customizable component. Designers design within the realm of what's achievable, and everything they change goes back up into the cloud, gets converted, and automates the full delivery in the process, and then spits out the right information to the supply chain. So that was really, that's, you know, the crux behind Riveia and where we've come from and then where we're going. It's very much not the vertically integrated business model that everybody is preaching as a solution, and it's not over standardizing. It's actually bridging the data between suppliers and designers, and empowering architects to design within the realm of what's achievable, and then automating a lot of the redundant work that we have to sort of go through in that inefficient process. So I guess there's a quick sort of overview of everything, and I'm happy to answer any questions and elaborate further.
Wow. So actually a lot to unpack here. Maybe one of the, I think there's a couple of conversations that we had about when we were warming up for this, about your critique of vertical integration. Maybe stepping back, I mean, so you have a clear critique of over standardization on the one hand, but maybe what do you see as the pitfalls of vertical integration, or how do you define vertical integration? Because there's aspects of vertical integration to what you're doing, and there's aspects that are different.
Yeah, so I guess the biggest critique of the vertically integrated business model being the solution, it is the fact that they're still, you know, vertically integrated. All it does is it allows you to bring the design effort, or bring the effort further forward into the design process. So you can achieve DFMA, and you can do these things, and with the hope of making it on the back end. But the biggest thing that my critique is, you're still engaging in or you're still using the same complex software stack. You're still pushing forward with this inefficient process. So that's where we saw this preach of standardization. And that preach of standardization is purely because mass production, you design it once and then you mass produce it, economies of scale, the price comes down. But the truth is, you know, you can achieve standardization within components, but if we leverage computational design and that, then we can do it once and we can do it in the algorithm, and then we don't need to preach standardization to that level. We can actually preach mass customization, which I think that is probably a definition that we should clarify. It's, it is, you know, designing within the realm of what is achievable. So having the ability to actually design to what can be built, rather than design intent. I think that the industry is built upon design intent, you know, drawings and then interpretation, rather than, you know, the idea of mass customization.
I think that's an important point. I think we've looked at it through a technological lens, but one of the things that Ryan and I have tried to do is to understand the kind of social economic histories of some of these more successful industrialized ecologies. And so it's interesting, like some of the things you're describing and some of the problems that you run into, both with vertical integration and the lack thereof, has happened in Japan. So in Japan, there was a drive towards high standardization and vertical integration. And then that led to some standardization across the industry, and then allowed for companies to almost de-integrate. So certain components, sub-assemblies were decoupled from their parent companies because the economics actually made more sense not to be in-house. But then some things, on the other hand, you could also say some degree, and I think you're alluding to this, vertical integration also prevents certain kinds of innovation because large players don't want to see new players emerging. So it's kind of tricky. On the other hand, we've seen in Japan what happened, and it was actually publicly funded, was that the mom and pop contractors there, was mostly heavy timber construction. They actually got infusion to be able to set up a kind of CAD/CAM cottage industry where the 100 or so details that were required to make like a very intricate Japanese construction got simplified into 5. So those details became, you could say, a kind of digital product. And in a way, and that's actually the dominant side of the industry. So someone like Muji, for example, is able to provide a product without actually having manufacturing because of that vertical integration, de-integration process. So again, like it's interesting. We don't have a lot of examples at a kind of, again, broad industrial ecology to be able to like predict whether these models will play out. But we certainly, certainly there are alternatives to the drive towards everything under one roof, the benefits of that. The big obstacles then again is when you develop a digital product, there is some need for stability in terms of manufacturing equipment or even the use of G code, and even those things right now in the US. Like, where's the chicken egg horse cart situation? What do you need for your digital product to be successful? Do you think the industry is ready for it, or do you see this as part of the is this a stepping stone to the ecology that supports a fully robust version of this business idea, or are you really, is it there already?
Yeah, well, I think like there's a lot to, I guess, unpack in that question, but it's really, if you look at the dynamic of the industry right now, is you've got some super progressive, previously vertically integrated companies actually decentralizing and using technology to enable a new way. But then you've got other companies, and they tend to be more developer driven, right? Or customer driven, that they're saying, well, let's take control of the whole process. And then we will standardize the consumer product offering, and we will push it forward that way, which is very much what we sort of saw with the automotive industry in that respect. But even when they took that to market, if you looked at the manufacturing, they quickly moved away into a decentralized approach, or and leveraging the supply chain. So taking control of the front end and then not having to own the infrastructure themselves. But then the biggest progression in a lot of the industry in the digital age is that we've start to see things decentralizing and other, the platforms enabling everybody to use their own infrastructure. And I think that that's where we're coming at this. We're saying, well, what if the whole industry, there's all this infrastructure, there's all this beautiful technology in terms of manufacturing methodologies there. How do we get that in the hands of the architects to design, and then design within the realm of what's achievable, but automate the process thereafter? How do we help them to do that? And then how do we all collectively bring the industry forward? So it's sort of, my pick was that we were going to start to see these big vertically integrated companies take a hold and limit the product offering, which I was scared that what we might see is a lack of architecture in the built environment, a lack of site and context relevance, that because of the over standardization. And I think that I steer clear of the word standardization. What we're doing is still standardizing, right? We're still breaking it down into kit parts and components, but then we're building it with the constraints in that configurator, or in that bringing it forward. We're bridging the data. But so yeah, there's a big fear for architecture that, and I think the architects are well aware of this model that's been sort of brewing and growing. And in a way, we just want to bring the data forward, empower the architect to design, and then the industry benefits massively from highly resolved design that then can be automated, the process to getting it to the machinery. So rather than designing, re-engineering, repackaging every bit of machine, a new CAD CAM software, a new detail, all this experience, all in pre-construction, by the way, that can't be financed. So there's a whole other thing with the financial model. We're bringing it forward. We're actually empowering the architect to design more efficiently. So our hope is that architects can not spend their time documenting, they can spend their time actually designing. And then we can automate and benefit from that on the back end, which, a proven case there is component-based design within the WeWork model, 65% cost saving, well on their way to 80% cost saving, purely by component-based design. So that's really my bone to pick with the vertically integrated. It's being preached over standardization. And really the benefits, if the tech is, if we build the right tech, we can all compete there, and we can all essentially be a powerhouse that's actually much bigger than any one company could be.
And so you've described actually your business model to us as actually making these digital products free to your clients. So where do you monetize on all of this, extensive R&D
Yeah.
and all these services? How do you see this business model kind of functioning in the
Yeah. So as we built out
day-to-day?
Riveia, we quickly realized that we had to hold the hand. We had to build this digital thread. We had to build the foundation ourselves. And we took a different approach here. We said, well, if we can go and build these out for free, then we can go and get all of the capabilities, bring that to the architects for free, on a platform. But where we're monetizing it is, proof in the pudding. We're going out and doing it, showcasing where you can save 30, 40% where we did initially, potentially 65%. And then we are commoditizing it on the transaction. So it's like we're giving it to the architects, which is the manufacturers now have this form of early contractor involvement in a product. So they're not having to hold the hand of the architects. And the architects are benefiting from actually having all the knowledge there, and a streamlined design process. And then we're just sort of sitting there facilitating that data bridge. And the approach that we've taken there is we realized we had to digitize the industry. So when we build a component, we're also building in the supply chain. Also building in these. So we're laying this digital thread through the whole industry, but then unlocks so much potential for other people. Right now, ERP systems are constantly talking about how they get BOM out of Revit, and then back and forth. What we're doing is we're unlocking the data there. We're enabling the industry to take their IP and their services, package it up into a digital product that protects their IP, but puts it in the hands of everybody to use.
Right.
And then they can't be value engineered out of the process. They don't need to be value engineered because now architects are designing with the cost up front. They're making those decisions at the outset. There is no need to value engineer or bid or tender projects. We're actually just streamlining that whole thing, and people's IP is protected. And they're not having to engage in that ECI that generally you do to win projects, and it costs you a lot of money.
So really, it's interesting that your value proposition is exactly where a lot of the software fails us currently, which is the translation from the design documentation to actually speaking to machines. So which just seems like a big oversight. So either we've seen the two models we've seen in many places is either a proprietary software package developed by a large company, or this kind of strange handoff between design side and manufacturing side, with the exception of the wood space, where you do get, and that's sort of in Europe, where you get certain companies that work with certain manufacturers in the kind of panelized realm, and you get a little bit more of that integration, but it's very much tied to the framing side of the business.
Yeah, and if you look at that process, no matter, like, there's great machinery out there, there's great technology, but it all takes that CAD-CAM link, and it's that missing data. So it's sort of, you can be highly skilled in designing for that machinery, but it's really, this is something we ran into at Studio Workshop, is we could resolve design to such a level, but the developer or the consumer wasn't willing to pay for that at the front end. You can't finance that, and you have to actually streamline that process. You get to the documentation, to get the approvals, to get to the first drawdown, right? And it was like the whole design build contract evolved out of that. So all we're doing is bringing that data forward, exactly like you said, and streamlining that and taking that missing bit out of the middle. It's like, we've seen so much in industrialized construction, people preaching faster and better quality. It's like, but with all this machinery and all this technology available, we should, and it's been proven that you can save, 65% cost savings is what you saw from one company taking this approach. Could you imagine what that does when the entire industry has this digital thread? We've got beautifully architecturally designed projects at 65% or more or greater than cost savings. Then what does that even mean for the built environment? What do we start to see? What do we start to see for the adoption of industrialized construction? So that's the missing divide really now, and we've seen it too many times where it's preaching better and faster isn't enough. because they'll just throw in the towel and they'll go back to the old way. But throwing cost savings and there's the sheer uptake and the sheer volume that collectively the whole industry can come forward.
No, and it's also something that's come up a lot in the discussions why, at least in the US and to some degree in Canada, why some of these technologies that worked in slightly more homogenous markets like Sweden or Japan, where you have a few players and a more kind of consolidated market, this hasn't worked. So in a way, you're implying that maybe we can skip the defragmentation phase, and really you could imagine that this is a different kind of solution, a more heterogeneous one to what has been a big obstacle to moving forward, where we, at least even in the volumetric modular space that we researched, there's 200 plus companies who all have their own specs, but who all, you know, with a different communication tool might see more value in a DFMA approach. So and maybe in closing, who are your biggest advocates? And I mean, not in terms of specific companies, because I know you can't talk about that. And what do they share in terms of what do they see as the value in your proposition?
Yeah, so I think it's a really valid point. Even as you talk about all the players in the industry, is really one criticism I might say here is that people saying you're automated tasks, so you're doing people that are sort of out of a job, and it's much less that we're actually automating processes that we don't need to continue. And by packaging it up into a digital product, you can easily add to that and add the sophistication. So we want the industrialized construction products to actually more R&D, more time to spend actually resolving those designs so that they actually are products and we can move forward, not one-offs. So by taking that approach and digitizing it, the teams can start to bring it forward, but also package their IP up in that and protect it in a digital product. So then we're going to start to see that industry coming forward. So if you look at our users, right? Architects quickly validated the idea that they wanted component-based design. They wanted the ability to design within the realm of what's achievable. They wanted a simpler design process, but they also wanted to know cost.
Right away. Yeah.
They wanted to be able to design and know what they designed was going to be built. It wasn't going to be value engineered out, and they weren't going to spend 80% of their time documenting it and then fighting for their design intent. It's like they could design within the realm, plug it in, and make sure it sort of comes together. They can also, under this model, which we can touch on after this, is we're giving them the ability to actually design their own products. So eventually, so when we open up the back end, you can commoditize on details, tectonics, full buildings. You can take everybody else's components and build in your own building typology that's completely customizable, but it's got, the Shigeru and Flare, or, it can have that flavor behind it. Or you could be a sole trader that develops, just sits in there and develops good details. So that's the architects, the manufacturers.
That's the one. Yeah, those are the folks that maybe understanding what's their incentive. You're taking some things out of their hand, but you're increasing their market.
Yeah, so the manufacturers don't have this early contractor involvement. They're not now having to educate everybody on designing for modular and then taking that design and restructuring it. And then, some of the players that have automation then have to restructure that for their machinery. They have to extract data out of a model, or generally out of a set of drawings. When they're lucky, it's in a BIM model, extract that data and try and convert it and run their whole process. So for manufacturers, it's like they're bringing everything forward, letting people design with it, and then they can automate as much as they want on the back end. Some of the other players there that say now we can add lines of code to that to program robotics, to automate other processes that, so the ability then is for them to spend the time in R&D they would have on redrawing things and early contractor involvement. They're now spending on resolving their processes and automating more process and bettering their product and increasing their profit margins, increasing their productivity, and a whole new sales avenue.
Through architects who are actually kind of like decentralized salespeople for them, which is a pretty interesting situation. Joel, what about the data there's an interesting, so you're working with manufacturers in a way to test these digital products to see if they're viable, to see if the G code works, right? And then you're working with, let's say, architects who are going to be using these digital products and who are actually going to be selling them in a way. What about the kind of the feedback, like what happens when the two sides are actually speaking through the digital product in a way, right? Is there, what happens when there's a conflict? Who manages that?
Yeah, so the answer to the question there is really architects generally want to push it to the limit, right? They want to break it. They want to see how far they can go. And that sort of creates a dialogue there that they're highlighting opportunities to further that product or, to commoditize on it themselves, right? If they want to break it and push it beyond that, then there's an opportunity for them to create something there. So they're sort of the one-offs, right? They're not really the majority of the industry. And so our platform right now, eventually we'll open that up and we'll have that back end to allow people to build and commoditize that back end. But right now it's an interesting dialogue or an interesting approach for architects to actually be restrained in that design. But then what I find is that they're tending to get creative with the constraints. And so if it was a vertically integrated business model or if it's a modular architect, they're generally just going, well, this is what we know, this is what we do, let's keep it simple. Whereas the architects that have sort of now got this extra knowledge, they're pushing the boundaries a little bit. And so I think that's going to help with the adoption of industrialized construction as well. It's not going to be just pigeonholed to the volumetric modular space. And the other thing is that, generally speaking, with a methodology, let's use CLT. If an architect wanted to produce a project in CLT previously, they would sort of have to commit to the manufacturer at the outset, get them to have to hold their hand. And what you saw was like redundant structure. So you saw walls in CLT that didn't need to be, or you never saw this hybrid structure. But what we're opening up now is this ability for the architect to get creative, but also look at hybrid structures. So then, in my mind, as this evolves and as the uptake grows and there's more diversity on the platform, you're now going to be able to see, you're going to see it coming, but you're also going to see manufacturers less likely to have to say, well, you have to use the whole system. They're just going to be, hopefully they're going to have the continuity running through the factory anyway and bettering their product, and
specializing more. It sounds like what you're alluding to is that they can focus on what taking advantage. Well, this is great, Joel. It's been a really interesting conversation, and what we want to do in the future is, as these, what we'd love to see is as these projects evolve and the use of this digital platform evolves, and we'd love to get you back and start, getting under the hood, IP with all the IP possibilities resolved. And starting to see how this actually, how this process works, because it really does in some ways change many of the biases we have, both about what we think is standardization, but also what we thought as architects, what the industry thinks is standardization, but what we as architects imagined maybe 10, 15 years ago was mass customization, which was also driven by mostly visualization tools. And so this is kind of what Ryan and I really appreciate about what you're doing, is it really challenges both sides of the discussion, the manufacturer and the architect. And we hope, we hope you all the best.
Thanks. Yeah, well, that's a big part of our take to market strategy, right? Is that we're willing to go out there and build these components. And when we do that, we're going into the manufacturers, we're breaking down their logic into the components, into, taking a DFMA approach and rebuilding it computationally. So we're sort of helping them and guiding their hands through how you create a digital product, but also how they embed their IP in something that is super robust, and digital. And then, as we open that up, we want to get more diversity on there for the architects, and I want to sort of see the architects start to push it, right? I'd love to, we even said we might even run a design competition internally on the platform, just to showcase how far industrialized construction or all these different methodologies could go in terms of the architectural side. I think that there's and then the whole computational side, when we open up the back end and allow architects to create their own digital products using other people's infrastructure, that whole dialogue and this whole ecosystem for us is when it really gets exciting. And that's something that we, we're really going to be working hard with the user base to make sure the value proposition there and that it's bettering it for everybody. So,
well, if there's anything we can do, let us know. Well, Joel,
cheers.
thanks again. Thanks again for joining us on Monex Voices, and we'll be in touch and following you closely. Have
Awesome.
a good day.
Thanks. Cheers, mate.